We'll learn about this chi-square test. Okay, it's a test that measures how and how a model that is going to be compares to an actual observed data. Okay, that means whatever the data that are going to be used, okay, that must be random or it must be drawn from the independent variables and also drawn from a large enough samples. Okay, here this chi-square test, if you see, are often used in hypothesis testing. Okay, see, previously we had seen about the t-distribution. Okay, that is also used in the hypothesis testing. In the same way, this chi-square test, which is also used in the hypothesis testing, and it compares the discrepancies between the expected results and the actual results. Okay, we can find out okay, the expected results, okay, the difference between the expected results and the actual results with the help of this chi-square test. Clear? So it's the main motto of this chi-square test. Okay, and if you see one example here, that is from the following data, test whether there is any significant liking in the habits of taking soft drinks among the categories of employees. Okay, that we have to find out. Okay, is there any significant liking in the habit of taking these soft drinks, okay, among different categories of employees? Okay, they have given the three different soft drinks like Pepsi, Thumbs Up and Mazda, and three different employees like clerks, teachers and officers. Okay, that's the observed data. Okay, this is the observed or the actual data they have given. Okay, here we have to make one hypothesis that the habit of taking soft drinks, okay, not depends upon the categories of the employees. Clear? See, whatever it may be the assumption, you can make it your choice. You have to make one assumption. Clear? Here the assumption we are making as the habit of taking soft drinks not depends upon the categories of the employees. Okay, to test the above hypothesis, the suitable chi-square test statistic is given by, okay, this it's not x square, it is a chi square. Okay, chi square is equals to summation oij minus eij whole square divided by eij. Okay, here okay, it's if you see this chi square r minus 1 into c minus 1, here the distribution with r minus 1 c minus 1 degrees of freedom at percentage loss. Okay, here itself you remember this chi-square formula. Here the chi-square is equals to summation oij minus eij whole square divided by eij. Okay, that's it. Okay, O means the observed frequencies and E is the expected frequencies or the values. Okay, O means observed, E means the expected frequencies. Okay, here observed values means already whatever the data they have given, these are the observed values, and here that is the expected values or the expected frequencies that we have to calculate initially. Here eij is equals to ith row total into j column total divided by n. Okay, n is the grand total here. Okay, see, for this data, we have to calculate initially the expected values. Okay, that is the calculation of the expected frequencies. Okay, we have to rearrange the table like this. Okay, the soft drinks, they have given three soft drinks of Pepsi, Thumbs Up and Mazda, and we have to write as a total here. Clear? In the rows we have to write clerk, teachers and officers. Here also we have to write as a total, and we have to calculate these values. Okay, these expected frequency values we have to calculate it. Clear? See how we got the value as 21.43. Clear? Herely I have mentioned here, that is eij is equals to ith row total into j column total divided by n. Clear? See, that means in this data you have to add this row and this column. Clear? To get the value here in this 2.21.43, what we have to do, you have to add this row total and you have to add this column total divided by the grand total. Okay, see, the grand total is 350. Clear? See, that means here 10 plus 25 plus 65, you will get the 100. Okay, and 10 plus 15 plus 50, you got 75. See, that means if you substitute in this formula 100 into 75 divided by 350, you will get the value as 21.43. Okay, in the same way here, how you got this 32.86 means, okay, you have to add all this 10 plus 25 plus 65, you will get one value into, okay, 25 plus 30 plus 60, you will get some value. Okay, okay, initially this value into this value divided by 350, okay, you will get the value as 32.86. Clear? See, in the same way you have to calculate all these expected frequencies. Clear? And we have to made one chi-square table here. Okay, OIJ means the observed values, that is the initial, okay, whatever the values they have given, these are the observed values they have arranged in one column. Okay, that is 10, okay, 25, 65, okay, like this they have arranged. And the expected frequencies, how we have calculated these expected frequencies, also arranged in the form of a column. And we have to calculate here OIJ minus EIJ divided by EIJ. Okay, sorry, OIJ minus EIJ whole square divided by EIJ. Okay, we will get the values like this. Clear? See, this is the sum of all this we got, that is the chi-square value. Okay, chi-square is equals to summation 0, that is OIJ minus EIJ whole square divided by EIJ, right? See, finally the chi-square value will be 6.165, and the critical value, if you see from the table, we'll get 9.488. Okay, here if you see, the calculated value will be more than the critical value. So here the calculated value of chi-square is more than the critical value of chi-square at 5% loss. So we reject the hypothesis and conclude that the habits of taking soft drinks depends upon the categories of the employees. Clear? And next we'll see one more example. Okay, suppose in an Mendelian experiment on breeding, four different types of plants are expected to occur in a proportion of, see, wherever you will get this expected, okay, like this, that means definitely that is okay, following a chi-square distribution here. Okay, that is expected or observed values, if you see, that is 9 is to 3 is to 3 is to 1, the observed frequencies. Okay, they will directly give the observed or expected like this. That means observed frequencies means definitely we have to go for the chi-square distribution. Okay, 891 round yellow, 316 sprinkled yellow, 290 round green, and 119 that is sprinkled green. Okay, find the chi-square value and examine the correspondence between the theory and the experiment. Okay, we have to find out the discrepancies between the theory and the experiment here. And the hypothesis we have to make it is assumed that the theoretical value corresponds to the experimental value. Okay, here we are making one assumption, and we have to calculate first the expected frequencies. Okay, these are the observed frequencies already they have given. What we have to calculate initially, that is expected frequencies. Okay, the total number of observed frequencies is 1616. Okay, the total, if you are adding all this, we will get 1616, and from this we have to calculate the expected frequencies. Okay, for round yellow, okay, we have to calculate, see, that is initially the ratio you see, that is 9 is to 3 is to 3 is to 1, right? 9 divided by 16. 16 means 9 plus 3 plus 3 plus 1, that is 16 into 1616. Okay, this total number of observed frequencies, okay, you will get 909. Okay, and next wrinkled yellow, the ratio will be the 3. Okay, that means 3 by 16 into 1616, you will get 303. And the third one is round green, the ratio will be the 3. Okay, again 3 by 16 into 1616, you will got as 303. And finally for wrinkled green, the ratio will be only 1. So 1 by 16 into 1616, you will get as 101. So we have calculated the expected frequencies this one, and the observed frequencies is this. And we have to, okay, made one chi-square table here. Okay, see, to test the above hypothesis, the suitable test statistics is given by chi-square is equals to summation Oij minus Eij whole square divided by Eij. Clear. For this we have to made one chi-square table. Okay, Oij, that is observed frequencies, and the Eij, that we have calculated the expected frequencies. Okay, from these two we will get this Oij minus Eij whole square divided by Eij. Clear. If you are adding all these values, you will get the chi-square. Clear. This is the chi-square calculated value, and the critical value we got as 7.815. Here the calculated value will be less than the critical value, clear, of chi-square at 5% loss. So we do not reject the hypothesis and conclude that the theoretical values are corresponds to the experimental values. Okay, see, that's all students about this chi-square.